Alright everyone, and welcome back to the AI Research Roundup. I am your host, Alex. Today, we're looking at a fascinating paper from the Papers with Code trending list, published April 26, 2025. It's titled Reservoir-enhanced Segment Anything Model for Subsurface Diagnosis. So this research tackles the tricky problem of finding hidden dangers under our urban roads, like cracks and cavities. It uses a technology called ground-penetrating radar, which employs electromagnetic waves to visualize what's underground. The core innovation is their proposed reservoir-enhanced segment anything model. This model is designed to exploit both the visual appearance of ground-penetrating radar data and, importantly, the subtle changes in those electromagnetic waves that anomalies cause. This allows for precise anomaly detection, achieving over 85% accuracy with minimal data and simple human interaction to boost reliability. This reservoir-enhanced segment anything model sounds quite promising for improving safety. And if you're interested in exploring the technical details or even trying it out, well, the authors have generously made their code for this work available on GitHub. You'll find the complete Res-SAM framework there, designed for this ground-penetrating radar under ground hazard detection. This includes their core PatchRes module, which is a specialized component that leverages reservoir computing concepts on image patches, the segment anything model integration, and even a user interface. Alright, looking at here, we get a good visual of the ground-penetrating radar setup. Part A shows the typical equipment, a host unit and an antenna. This antenna emits electromagnetic waves, or EM waves, down into the ground. These waves reflect off subsurface anomalies and are then processed. Part B then shows an example of GPR B-scan data. This B-scan data, which is what the paper specifically refers to as GPR data, visually represents these reflected EM waves. You can see an anomaly region highlighted, and the figure illustrates how these gray value columns in the B-scan data correspond to variations in the actual EM wave. Okay. So building on that understanding of ground-penetrating radar data, here gives us a clear flowchart of the reservoir-enhanced segment anything model framework itself. It's broken down into two main phases. First, there's feature collection. This phase starts with non-target ground-penetrating radar data. Basically, data from areas known to be normal. Small patches are extracted from this normal data. Each patch is then processed using a core component called a Dual-Directional Echo State Network, or 2DESN. This dual-directional echo state network is a type of neural network designed to capture how the electromagnetic wave data changes both horizontally and vertically within a patch. The features derived from these normal patches are collected into what the paper calls a feature bank, which acts as a baseline of normal characteristics. Then we move to the anomaly detection phase. Here, simple click prompts, like a few mouse clicks from a human operator, are given to the segment anything model, which then provides an initial rough candidate anomaly region. Local patches around each point in this candidate region are again fitted using the dual-directional echo state network to get their dynamic features. These features are compared against the feature bank to identify abnormal patches, which are then merged to define the final, more precise anomaly region. So, after that anomaly detection process we just discussed, here provides a great visual of the results. The top row shows the raw, ground-penetrating radar data for various subsurface issues like cracks, manholes, and cavities. The rows below, then, illustrate how the system performs with different numbers of human click prompts, indicated by those small green and red dots. You can see the initial, broader candidate region suggested by the segment anything model as a blue dashed box. But then, the heat maps, which transition from blue for low to yellow for high, show the anomaly likelihood calculated from those local dynamic features we talked about. This refined understanding leads to the final, much tighter red box, which is the anomaly region pinpointed by the full reservoir-enhanced segment anything model. Alright, so after seeing those visual examples of how the reservoir-enhanced segment anything model refines the anomaly regions here gives us a quantitative look at its performance compared to other methods. These line charts show two key metrics. On the left, we have the F1 score, which is a common metric in machine learning that balances how precise the model is with how many of the actual anomalies it finds. And on the right, there's the area under the ROC curve, often called AUROC. This measures how well the model can distinguish between an anomaly and a non-anomaly across different sensitivity levels. Both charts plot these scores against various prompt configurations, like 5 positive and 5 negative clicks, down to just 3 positive clicks. The red line, representing our reservoir-enhanced segment anything model, consistently stays at the top for both metrics, showing superior performance. Notably, its performance remains high even with fewer prompts, especially in the challenging 3 positive and 0 negative clicks case, where other methods tend to drop off significantly. This really highlights its robustness. So, building on that robustness we saw in the charts, now gives us a side-by-side visual comparison. Each row here corresponds to a different type of anomaly, such as a cavity, a crack, loose material, a manhole, or a pipe. And for each of these anomaly types, we see results under 2 different click prompt conditions, one set using 5 positive and 5 negative clicks, and another using 3 positive and 3 negative clicks. The columns then show the original ground-penetrating radar data, the prompts, and the anomaly regions marked by red boxes from our reservoir-enhanced segment anything model, compared to scribble prompt, MI deep seg, and simple click. Visually, you can generally see the reservoir-enhanced segment anything model provides more accurate and complete red boxes around the anomalies in these examples. So those visual comparisons really underscore the practical advantage. This reservoir-enhanced segment anything model. It's not just about better scores, but about providing a more reliable tool for subsurface diagnosis, even with limited guidance. This is a big step for efficiently identifying hidden issues underground. Well, that's all the time we have for this AI Research Roundup. Thanks for tuning in. I'm Alex.